we'll revisit this problem again about the Frobenius solution. So we write the solution using the Frobenius theorem, and I'm not going to do all of that again. What is the focus here is we only focus on the last part where we write the recursion relation. So we have a sub k plus 1 equal to that. This is corresponding to r equal to 1/2, which is the higher, the greatest solution to the initial equation. Right, now we only focus on that recursion relation. Right, copy that here. Right, so for that, now we use the calculator for this one, so there's a calculator. Right, before we use the calculator, here's a few things. In the calculator, the index actually will be in terms of n, and that actually this one we have to write in terms of a to the n, but it's u to the n. That's how the calculator wants to do it. So u to the n. So in that case, what we did was we let n equal to k plus 1. So because of that, k is equal to n minus 1. So we substitute all of that back into the equation. So everything must be in terms of n. All right. And also we know that r equal to 1/2. We have that from the last part. Right. I put all of that in. We're going to have the calculator use u instead of a. So to say u sub n equal to will be a big fraction. A sub k will be u of n minus 1. K is going to be n minus 1. That's k plus r 1/2 plus 5. The bottom, k is n minus 1 plus r plus 1. R is 1/2. And then 2k, 2n minus 1, so 2n multiply them out, 2n minus 2 plus 2 times r is 1/2 plus 1. Right. Simplify this. We have u of n minus 1. The top we have 5 minus 1 is 4, so it will be n 4.5. We use the calculator, so we're just going to leave 4.5. At the bottom, minus 1, 1 cancel, we have n plus 1/2. And then let's see what we can simplify here. Right, so that minus 2, this is 1 and 1, so pretty much it cancels everything. We only end up with 2n. So let's say n plus 1/2. Right, so that is only for the calculator. Right, in calculator, here's a few things we have to do. First, we hit mode. We're going to keep things in sequence. So that in sequence. That's good. And now we have to enter the sequence. Y equal to, as first now it would be in terms of sequence. Right. So notice that what we need is we start from A naught. That's the first thing we need. A0, A1, A2, and so on. So the minimum here, that A naught equal to 1, and we have the minimum of 0. So meaning A of 0 is equal to 1. That's exactly what we have. So A0 equal to 1. Right? Now, the A sub n. Now, that's going to be a little complicated. To enter fraction, what we do is hit alpha y equal. The first option is the fraction, so what I need to do is just hit enter. Now, this is u of n minus 1. Notice the way they write it, they do not write a subscript, they use in the function notation. So instead of write u of n minus 1 with the subscript, we have to say u parentheses n minus 1. So second 7, you see a little u right here, u of n. Right. In order to enter n, we look at this button. We have the x. We start with the function t parametric, theta, polar, and n sequence. Again, if we hit both, we have function parametric, polar, and sequence, which corresponding to these 4 coefficients. Right. Get back to y equal to though. So u equal to n minus 1. So hit n minus 1. Alright, and after that, we have n plus 4.5 divided by the bottom n plus a half. I have to say 0.5 times 2n. 2n. Right. If we hit second graph, there's our sequence. This will be the sequence of numbers. The A0, A1, A2, and so on. It's look complicated. I mean, it is a decimal, so it's not what we want. We want fraction if it is possible. Right. It is possible. So again, second 7 is get back to the little u. If we want A1, that's what the second term is. We can change to fraction, and that's what we have. So there's no problem there. Now we want the whole sequence, the first 4 terms, right? So we hit second u. What we do next is we enter the list of numbers. A list is just like a set, open parentheses, and then you see above the parentheses are the curly bracket. We use that second. We have the curly bracket. We want the first 4 terms, 0, 1, 2, and 3. If we want more, just put a few more. But we only do for this set. So second, close curly bracket, and that. So we evaluate the sequence for the first 4 terms, U0, U1, U2, and U3. There. And all we need to do is change this to fraction. Math, convert to fraction. And that's what we have. Now if we go back to the previous page, and we compare the coefficient at the end here with the coefficient we have on the calculator. As you see, they would be the same. So this is not a different way to do the problem. This is just a way to handle the recursion relation. And in that case, we use a calculator to do that part for us, so we don't have to do the relation by hand.